Hello. Welcome everyone to the next lecture of data analytics using Excel. I am Dhruv. I will be your tutor for the day. In this lecture, we will be working with something which is very interesting, a solver add-in, right? We have already worked around with data analysis add-in, and it's just below that. The important part here is we'll be trying to increase your efficiency by a lot, and we'll be giving you a thought process which you might not be able to think. So this is very essential for you if you're going to work in a particular MNC which is, let's say, producing something, or if you have to take decisions from a managerial point of view, right? This might not be very useful if you're just a business analyst, but this might be very useful for you if you're actually a shop owner or you have your own business running, because sometimes you want to maximize the profit, sometimes you want to minimize the cost, and sometimes we want our margins to be at a certain level for growth, and sometimes we do not know what exactly should we do and how much should we produce, what should we reduce and what not, to exactly make sure our entire inventory is being used very efficiently and all the constraints are being followed. So this entire concept is based on LLP, a mathematical let's say technique through which we are able to get to the maximum or minimum points, where we are trying to maximize those constraints which will benefit us, or minimizing the constraints which are going to not benefit us or whatnot. It can be reducing costs, increasing profits, or increasing margin and whatnot. So we'll be working around with that. One request that I have is to work with me when I'm actually going through one particular worksheet in the workbook. Look what I'm doing and then go ahead and do it in your Excel file as well. Do not wait for by the end of this lecture and then complete it, because we'll be working progressively. The first example might be very easy for you because I've taken like 5 examples and they are progressing one by one. The level is actually increasing till the 3rd, 4th, 5th. They are almost at a similar level. So while I work with all of these examples, you need to understand the process first, and then you will be able to apply it in the real world scenarios, which will be, let's say, the 3rd example, 4th example, 5th example. Nobody is going to ask you how you can use solver add-in for example 1 and example 2. So without delaying more, and I won't bore you more, let's actually try and work around with solver add-ins. So as you can see on your screen now, this case is related to 2 products, product A and product B. I'll say category A, category B. And then the profit that I'm going to get from one product is 20. Profit that I'm going to get from the second product is actually 30. Unit produced are 0 here and 20 here. Now the answer is already in front of you. If we can produce the maximum of, let's say, 20 products, this is what we are going to get, right? A total of 20 units will be produced for category B, and we are going to get the maximum profits of 600. But what if you have a lot of product A, B, C, D, and you have a lot of constraints attached to all of them? It might happen that you are running a particular factory in which you can create only certain level of products in the entire year, and you actually have to maximize your profits. In that particular scenario, it might be a little difficult for you to understand what exactly do you need to produce, how much. So just understand the process and you will be able to imagine how you can apply it to very vast data sets altogether. So for the same, they're actually going to go to solver. Second thing, all of this is already there because I just ran the test. I'm actually going to delete all of this so that I can explain all of this to you. This didn't got deleted, and yes, so I really want to maximize the profit. So my objective will be in cell D4. The total profit is here. I want to maximize it, and you can change the number of units produced, right? The other constraints are that I cannot go beyond 20 products. So I will actually click on add here, and I will add a particular constraint here. So this cell can be equal to or less than 20. Or if I want, I can also give a reference to this particular cell. I will add that. Another thing which you might have to remember is that product A and product B can never be negative, right? We cannot produce negative quantity. So the other constraint that we have to follow is it should be greater than or equal to 0, and we're going to click on add, and the same is true for C3. It is going to be greater than or equal to 0. And I'm going to click on OK now here, and you can see there's a lot of things that I have given here. Although you can minimize the profit and you can maximize it. If you're going to click on minimize, then it will actually take the value in between, and it will not produce anything for me. It will be at 0. right? Because if you're not producing anything, then it will obviously give me the least profit, and 0 is the minimum value that I can go for. I can go to a certain level of profits also if I really want to. If I want, let's say, only $320 of profit, I can just write it here and do it. For now, we'll actually work around with maximum, and this is all you need to work around with. Do not worry about these for now. Although if I'm going to, let's just go here and choose any particular form, I can go to simplex and whatnot. You will be able to see what exactly is going to happen. Although the explanation of all of them is also written here. Select the GRG nonlinear engine for solver problems that are smoother nonlinear, and select the LP simplex engine for linear solver problems. So let's go ahead and select the GRG nonlinear one only. I don't feel like any problem here. And if I'm going to click on solve, we'll wait for some time and let's see what exactly is happening. Oh yeah, now you can see the results have been changed here. The product B is actually at 20 and I have the maximum profits here. I can restore to the original values, nothing will be given to me, and the solution can also be given to me here. Although I can also take the report with me, I can take the answer, I can take the sensitivity, I can take the limits as well, whatever I want. But for now I do not want anything, so I will not click here. If I'm going to click here, it's actually going to create another sheet for me. So let's try that as well. I'm going to click here and you can see there will be a report, an automated report which will be created by Microsoft Excel for you. So here you can see the constraints which were being followed, the variable cells and the objective cell, and it will actually give you the interpretation of what exactly happened and how much time it took to actually run it and properly solve the entire problem for you. So that's how you can actually get the reports, but our objective is to not work around with them for this particular example. We'll delete this, and now let's try to work with something even broader. The second thing which we need to work on is to actually produce units, but now not only the profits are there for the product A, product B, and not only do we have the constraint for units, but we also have a constraint on resources. Now if you would have seen in the last lecture as well, we need to work around and add more constraints, just the way we did in the last lecture. So let's see how we can do that. Right now we have only like two random numbers here and we have certain profit here. So let's try to solve the same example again, and we're actually going to delete all of this. Anyway, we have to add a lot more. So maximum, I'm actually going to delete these. I'm going to delete these. Although E4 is already chosen, which is perfect. Maximum value, I want to change cell C2 to C3. The constraints will be units produced are supposed to be greater than or equal to 0. I'll click on add. Product B also greater than or equal to 0. Now you can imagine how I can work around with so many different types of product in one particular go. And then I need to click on add here as well. And the second thing is the total resources which are being used should be greater than or equal to the availability. This should be equal to the availability, and I'm going to click on add here. The total number of units can be equal to or less than 20 again. I'm going to add. Constraint must be a number, specific reference or formula with the numeric value. So right now selected B6, which is something I don't have to select here. I actually have to select cell B4, and constraint is supposed to be 20. And I'm going to click on add, and okay, that's all. I need to go to cancel instead, so I can see all the constraints in front of me, and this is how the entire problem set can be solved. I can maximize the profit, and Excel will tell me what to produce, how much, and how I can go ahead with the same. So if I'm going to click on solve again, I got the pop-in in front of me, and I can say that okay, produce 20 products of A, and the resource is also only at 4, and the maximum profits I can gain is 80. So I can go ahead and click on okay, and I am retaining that. Although as the last example, you can also go ahead with the answer. Now the other thing which you might want to actually work around with is this thing. Now you can see a very complex example in front of you. This is how the examples will look like in real life also, and whenever you're going to interviews and you're talking about that, okay, I know solver Arden, this is the type of example they will be giving you. So from factory A, you actually have to deliver products in warehouse X and warehouse Y. I'm just trying to explain you what this entire case study is all about. And from factory B, you have to go to warehouse X and warehouse Y again, right? These two from factory B and these two factory B. Now, cost per unit is actually going to be this, and the number of units that you can produce is also written here. That's 12.55 and so on. So what you need to do here is actually to reduce this as much as you can. So let's say we are at 0, 0, 0 and 0 for now. That is the total cost that we are going to get is 0 for now, and the total cost for everything combined is also at 0 for now, right? So this is not total cost, this is total only because total units transported is having a constraint. So the maximum units that we can maybe transport from all the factories combined, it can be 30, and the maximum number of units that we can actually send across from factory A can be 20, and the maximum products that we can actually go around and send from factory B can only be 10. So right now we have a differentiation in terms of factory A, factory B here, but we have a combined effect of 20. We can send 20 to warehouse X also, we can send 20 to warehouse Y also, and that's why you can see I have given a particular formula here that I actually summed both of them and I wrote it here. So now why this is necessary, let's first try to understand what are the constraints that we are going to follow before this. Factory A can have a total production of 20, factory B can have a total production of 10, or maybe transportation can only be 20 or 10, right? So from individual basis, I actually segregated them into a single column which will have a constraint, and based on these we'll be changing these. So these will be the cells which will be changing. We want these to be changed. We'll have a total constraint of unit transported, and these two will be the other ones which will have number associated with it as a constraint. So now let's see how we can work around with the same. I'll delete all of these and this as well. So instead of maximization, we have to reduce it. So let's try to reduce the cost. We are going to click on total cost here. We're going to change these cells, these cells, and then other thing is to add the constraints. Total production can be always less than or equal to 20 for A, and for H3 it can be less than or equal to 10, and then number of units transported should be at least 0 or more than that. That is a positive value. The same is true for this one, a positive value. And then for C4 we're going to work with the same, and then we have T5 less than or equal to 0, add, and total units transported should be less than or equal to 30, right? So this is how it will look like. Let's click on cancel now. All the constraints have been added now, and let's click on solve and see what's going to happen. And I want this to be just right there. And one thing which I could see here, that okay, if our total units produced are, let's say, nothing, right, then I'm actually going to have, let's say, 0 cost attached. That was the entire agenda of minimizing all the cost. The other thing which you might want to work on is actually to use solver and work around with these constraints that you have added here. So instead of adding these constraints here, let's see how we can give that a minimum limit of 20 should be there. So each factory is supposed to give at least 20 products as a whole, right? So let's actually go around and add these. So instead of these being the maximum, let these be the minimum. So factory should be more than this than 20. Add this, and this should be then this, and it should be this, and add, and this should be minimum 30, and add. And now let's see the constraints that we have added. Now let's try to solve this. Click on OK, and now you can see we have the answer in front of us, where the if we have to produce at least 20 from factory A and 10 from factory B, the least cost that we can get is 130 by actually producing 20 and sending it to warehouse X, and then producing 10 and sending it to warehouse X for factory A and factory B. So this is how we are going to solve a complex problem. Now the next thing will be staff scheduling and portfolio optimization. So it's just like how we had it before this. We actually going to reduce the cost here. The constraint will be the required number of hours should be at least 24, right? And then the maximum budget that I have is also 500, right? So hourly rate is one thing, right? And the total thing that I'm going to get should also, the constraint of reducing the cost will also again have a constraint that it can maximum be reduced to it can maximum be 500. After that, do not give me the answer. And staff A, staff B and staff C are going to have 8, 12 and 10 as total, right? So you can work around with that. Although hourly rate is 20, 25, 30, 75, maximum budget is going to be 500 for me, and you can work around with the same. Then we have portfolio optimization problem, where you can see I have expected return, risk level, amount invested and total return, and you actually have to increase the total return as much as possible. You have a total investment amount that, okay, there's a particular investor and you can only invest 10,000 rupees in stock A, 3,500 in stock B, and there is no constraint for stock C. You can invest as much as you want to, right? So you actually need to work around with two constraints now. First will be risk, then we have a maximum investment, and amount investment will also have a constraint of it cannot be less than 0, right? So be very mindful about the constraints which do not seem like that, but it is minimum of 0. So that's there, and then you're going to have a total return. So these two, staff scheduling and portfolio optimization, will be homework for you. You can go home and you can actually see how these two are also going to work, and then if you're able to solve both of them, you'll have a confidence that, okay, now you can work around with solver problems. So that would be it from my end. If you have any doubts, you can always contact me. I will love to help all of you. Thank you everyone for joining.